Hello everyone, my name is Dewa. This is a demonstration for BIT362 Digital Forensic for Assessment 4. The selected topic is Docker Forensic. The purpose of this investigation is to identify how upload the download activity can be traced in a Docker container environment. The investigation uses 5 forensic techniques. I'll show you here, as you can see. The first technique here is the Docker container log analysis. I use the docker logs command to collect activity records from the running container, and the logs show the page view, upload, download event. Each event includes UTC timestamp, the source IP address, the file name, and SHA-256 hash, and the user agent. This helps identify what action occur when it occurs. However, if the activity comes through the Docker port mapping from the local host, the source may appear as the Docker bridge gateway rather than a real external user. Therefore, this evidence is useful but should be confirmed with the other technique. And the second technique is the network traffic analysis. I use TCP dump to capture the traffic while the upload and download action were performed. The packet capture was the open in Wireshark. Okay, here I already used the Wireshark here. This is the evidence shows the network connection, that traffic. I use the filter here for the client, the host of the Docker, and HTTP request type. In this control lag, the traffic is HTTP, so when I filter it, HTTP, you can see there's a host here, so the upload and download request path can be seen in a real cloud or production system using HTTPS. The content would be encrypted, but metadata such as an IP address, domain, port, and the timestamp would still be useful. Next, for the technique number 3, the third forensic here is a hash and metadata analysis. I calculated the SHA-256 hash of the original file here, stored in the Docker volume, and the downloaded file will be matching. Hash values show that the file content did not change during the upload and download. The start command also shows file size and timestamp metadata. This is important. As you can see, this is the host. The values provide integrity of evidence, while metadata helps establish a timeline of a file creation and modification. And next, the fourth technique is Docker file size, file system and volume analysis. I inspected the Docker container configuration and identified the mounted volume used to store uploaded files. I then check the uploaded file from the Ubuntu host from inside the container. Port location showed the same file and matching the SHA 256 hash. This proves that evidence can exist in more than one location inside the running container path and on the host mounted volume. This is important in Docker forensic because deleting a container may not always delete a volume data. So next to the fifth of the technique, this technique is an IP and MAC spoofing attribution test. I created a second Docker here as a client and assigned it a custom IP address, and the client then uploaded the evidence file to the target Docker web container. And the target application log recorded the source IP address as the one I created, 172.20.0.99. When I see the logs, you can see the source of IP address here, which match the spoof client container. The MAC address is not visible in this application log because the HTTP logs normally record IP level information, not layer 2 MAC information. However, Docker inspect a packet capture can be used to confirm the container's assigned MAC address. This shows that spoofing can mislead basic log analysis. So investigators should correlate application logs, Docker inspect output, network captures, timestamps, and file hashes. Alright, I think that's all of my investigation. Found that no single evidence source is enough by itself. Docker log showed user action, packet capture confirmed the network activity something. Thank you very much. See you.